It's loud. It's powerful.
It has steel balls, 6 per engine.
Equipped with several counter-rotating cylinders.
It has a large revolving screw-shaped shaft.
If it's off kilter, the engine will vibrate.
A central shaft to which an axle and wheels are attached. They begin machining the shaft. This digital lathe machines the exterior surface of the part.
First, the outer casings are taken off.
The balls go through a furnace to harden.
With only a few seconds, the cob is completely stripped of its covering.
This heavy piece of steel is the undercarriage,
Powering the engine.
And anyone with an appetite for feats of engineering.
You know you're in a tight situation.
First, they check the water tightness of the cans. They also control the filling weight and the quality of the kernels.
A robot applies sealant to the rear cover.
And now it's time for the forms to shed their latex skins.
You might be wondering where those 3 holes came from. The holes in which the pistons move up and down. The outer ring enters the grinder.
And then fit the top and bottom assemblies together.
the piston is now slid into the cylinder.
The piston moves upward, compressing the mixture. Then it drops the crankshaft into position.
And the searing heat hardens the steel
The spark plug ignites the gasoline.
to snugly grip.
The hole is enlarged on its sides as required by this machine tool.
They coat the rings with thick oil.
Then a press bears down to make a tight seal. The foreign material remains on top.
They heat it and press it onto the crankshaft.
They fit an air filter into its slot.
The black tubes running front to back are the camshafts.
Here, they're lined up, ready to be handled by the kernel remover.
A ball divider positions the balls. Robots install them into the cylinder bores of the engine block. The tool is lubricated so it won't tear the aluminum while stretching it. A process that happens in each of the engine cylinders. Insert the inner ring into the outer ring.
Next, they load steel rods into a slowly revolving device. A press pushes pins into the assembly to hold everything in position.
They classify the steel balls according to size. This ensures the valves open when the pistons are in the right position.
They round the tips of the rods and then carve necks below.
A steel connecting rod attaches each piston to the crankshaft. A robot lubricates the 4 bearings on which the crankshaft will turn.
Inserted into the piston.
Till it's rock hard and transparent.
Next comes the ball cage, a metal cage that retains the balls in position.
Because there's always someone who needs to be locked up.
Those rough balls go into a grinder. As it turns, it transfers power to the transmission.
They install studs in the outer framework.
They provide each cylinder with a spark plug and 4 valves.
This filling machine can handle 3 to 450 cans a minute.
Now they install a steel disc with teeth called the reluctor ring.
A liquid sprinkled on the machine part cools it during the process.
Coolant keeps the tool from heating up and getting too soft to do the job.
Robotic arms pass it down the line from station to station until 20 tooling machines later, it's fully formed.
Now it's time to stretch your imagination by making interesting shapes with the finished product. Bit of a loose device.
The pistons come next.
They need to be toughened up by replacing mortal muscle with mechanical torque.
Car engines work by internal combustion. They bolt it on manually with a tool called a multi-spindle torque gun.
Sprays of water and oil cool the part, which heats up due to friction.
As it cools, it shrinks to a tight fit.
The swivel link fits into the little grooves in the framework.
Elsewhere in the factory, meanwhile, the crankshaft is slowly taking shape.
It's time for the ultimate test.
A water-based liquid keeps the ring from overheating.
This liquid mix allows for the transporting of the kernels without damaging them.
This robot is applying sealant to spark plug tubes before inserting them into the heads. Lubricating oil will cling to the grooves in this pattern, enabling the pistons to move smoothly. The lubricant also acts as a coolant because the aluminum heats up as it's being worked.
The machining of the shaft is now almost completed.
Don't just lie there.
Pierce the shaft.
The unloading of many trucks of this size will be needed.
A machine squirts grease evenly, then inserts a rubber seal to contain the grease, causing an explosion that drives the piston downward.
Filling the cans is done from this rotating filling machine.
Here, they finish it off by machining the cylinder bores.
And the hole is now cleaned out with compressed air so that they can proceed with a visual inspection.
Now, workers can close up the back of the engine block.
And now you have a finished swivel.